Hello students, welcome to my next video. Now we are going to discuss on type 3 problems. That is the particular integral of third type, which is in the form of the polynomial function. That is the phi of x is a polynomial function of x. So we have particular integral is equal to phi of x divided by f of t. So this pattern is the third type. Okay, here you can assume phi of x to be a polynomial function of x. Alright. Okay, so in this case, how are we gonna do? In this case, we will have to apply something called long division method. Okay, you got to put it in the form of, here phi of x will be in the descending orders of the powers, and here the divisor is going to be our f of d, but ascending orders of the powers. This is descending, this is of course ascending orders of the powers. Okay, so here f of d, the powers are descending here, and here the powers of d are going up. Understood? So this is how you have to arrange the divisor and the dividend, and then apply the algebraic long division method. Got it? So apply the long division method, and whatever the quotient you get will be our particular integral. This is the quotient. Okay, so the quotient remainder will be anyway 0. Okay, so we get a quotient, and our quotient will be equal to, the quotient in this case is going to be our particular integral. Particular integral means y, that's it. And yc we find it using our traditional methods. Understood? So let us see a problem, then you get to understand it clearly how to apply long division method. Okay, let me take up a simple question and solve for you. Now the question says, okay, so the question says solve y double dash plus 3y dash plus 2y is equal to 12x square. Why will this come under type 3? That is the first question what should arise. This comes under type 3. Why? Because you can see the right hand part. This is of course this is a non-homogeneous differential equation, and this right side, that is our function phi of x, is a polynomial function of x. Okay, hence it comes under type 3. Anyways, let us see here how to solve. The initial step is to put the given equation in the operator form. So applying that, d square plus 3d plus 2 times of y is equal to 12x square, where capital D is equal to d by x. Understood? So going to the next step, the auxiliary equation states f of m is equals to 0, so m square plus 3m plus 2 equal to 0. Finding the factors for 2, we get 2 and 1, which are going to add up to give you the middle term, that is 3. So m square plus 2m plus m plus 2 equal to 0. Taking out common by grouping them, m into m plus 2 plus 1 into m plus 2 equal to 0. So we have m plus 2 into m plus 2. Therefore, m is equal to minus 2 minus 2. Implies the complementary function yc is given by, these are unique roots. So we have c1 e to the power minus 2x plus c2 e to the power minus 1x. So this is the first part of our solution. Next, coming to the particular integral, yp is given by phi of x divided by f of d, which is equal to 12x square divided by, what is f of d in this case? d square plus 3d plus 2. And I told you the numerator should be in the descending orders of the powers, and the denominator should be arranged in the ascending 12x square here, and this goes to the divisor part. So 2, that is the constant comes first, next d term, next comes the square of d. Okay, this is how you got to arrange it. This is a very important step. You guys have to make a note of this. If you do it the other way around, for certainly you will never get an answer, proper answer, I mean to say. Alright, so now how are we going to apply the long division? Let us assume that this is a working column. First step. What is the first step? We have to consider 12x square. 12x square divided by, so let us do that. 12x square divided by 2, we are going to get 6x square. That is the first term of our quotient. Okay, now 6x square into this entire thing, we got to multiply everything by 6x square. Let us see that 6x square into 2 plus 3d plus d square. That is equal to 6 2s is 12x square plus 6 3 is 18 d of x square. This is how you got to take. See, x square is a variable and d is, what is d in this case? We have defined just now here in the initial part. D is d by dx. So you got to find the derivative of x square, and then coming to the next part here, d square of 6x square. So 6 is a constant, comes outside, d square of x square. So this is how you got to do this. Whatever the product you get here, 6x square into this entire polynomial of d, you are going to write it here. It's absolutely the similar procedure what we are going to perform in the algebraic long division method, which you might have studied in your 8th standards if I am not wrong. Anyways, coming back to this, so this is going to be 12x square plus 18 as it is derivative. The first derivative of x square is 2x plus 6 as it is. You got to find the second derivative of x square. First is anyways 2x, so second derivative will be just 2. Okay, so simplify ahead and then you get 18 2's 36x plus 12. Bring it and write it here. 12x square plus 36x plus 12. Subtract it by changing the signs of the second terms. Alright, so 12x square minus 12x square gets cut and we are left out with minus 36x minus 12. You got to consider only the second sign, not the previous sign. The sign which you have obtained after changing it. Got it, guys? Now, let us divide this first term by this 2. So, this is the second step what we are performing. Minus 36x divided by 2 is going to become minus 18x. This is our second term in the quotient. So, once again, the second term in the quotient has to be multiplied by in the throughout of the polynomial in D. That is the divisor. 18x with a negative sign is supposed to be multiplied by 2 plus 3d plus d square. Got it? So again, now let us apply the proper multiplication along with the division, of course, derivatives. Minus 18 2s will be minus 36x minus excuse me. So 18 3s is 54, the negative sign. Next, derivative of x minus 18 times d square of x, double derivative of x. So let us see here, minus 36x as it is, minus 54 into derivative of x is 1, minus 18 times double derivative of x, that is differentiating 1 again further, we are going to get 0. So this term will be vanished and we are left out with minus 36x minus 54. Go put it here, minus 36x minus 54. Subtract it by changing the signs. Of course, the first term will get cut. That is the purpose of taking the division. First divided by first term here is the purpose only to get this first term cancelled, right? Anyways, so we are now left out with minus 12 plus 54. So how much are you remaining? 4 minus 2 is 2, so 442. So that is the remainder, but still no remainder. We will do it until we get 0. So let us divide again 42 by the first term in the divisor. Here this term divided by the first term. 42 by 2. How much are you going to get? 21. So the third term in our quotient is going to be 21. So multiplying 21 by 2 we get 42. and multiplying 21 by 3d, that is derivative of constant is going to be 0, so next term will be 0, and then second derivative of course is going to be 0. So you don't have to write that, only the constant part if you write that would be more than sufficient. Subtracting it you are going to get 0. So this long division has to be performed till you get 0, and blindly you are not going to do any further simplification. Blindly pick up your quotient in this long division, and that is our particular integral in this case. Understood? Therefore, in this case, yp is equal to 6x square minus 18x plus 21. And coming to our last step, that is the general solution of the given differential equation is given by y is equals to yc plus yp, which is equals to, what is yc here? c1 e raised to minus 2x plus c2 e raised to minus x. Again, adding up yp part also here, we get 6x square minus 18x plus 21 is the final part. Understood guys? No further simplification is necessary, and it is not possible also.